Hello, and welcome to today's biology lesson. Now, let's not just dive right in. Let me take a moment to tell you what this video is not about. Topics covered in our textbook. For those of you that don't like meiosis, mitosis, good news. Tired of the boring old four-chambered heart? Good news. This is for the mathematical biologists. This is the chi-squared formula. The formula goes as follows. Sigma, the quantity O minus E squared over E. Now, let's look a little further into what all that means. The sigma, or sum of outcomes, is used in the equation to show that you must add up the sum of the outcomes you've calculated. The second part of the equation was the quantity O minus E squared over E, and you're probably wondering what these letters mean. The O is for observed, or the outcome that you actually see at the end of the experiment. The E is for expected, the outcome that you expected prior to conducting the experiment. A very important part of a successful chi-squared experiment will include the null hypothesis, or H0. This says that the experiment results are solely due to chance and nothing more. So now an attentive student is wondering, what do you do once you get that chi-squared value? Well, there's a lot that goes into that, but the first part is the degrees of freedom. You can find the degrees of freedom by taking the number of outcomes and subtracting it by 1. That'll tell you where to look in terms of the row in the critical value chart, which is shown here. Let's say there are 2 possible outcomes. Subtract 1, and now you're going to be looking in the 1 row. In the context of AP Biology, we look at the 0, 5 column, so only look at that one. Let's say you do your calculations and you get a chi-squared value. What do you do then? This is where the null hypothesis comes back into play. Say you have 1 degree of freedom and a chi-squared value of 2. Because 2 is less than the 3.84 value, you would accept your null hypothesis, saying the results are strictly due to chance. However, if you had a chi-squared value of 4, you would reject the null hypothesis, saying that you're suspicious some other factor could be at play.
Say you're flipping coins on a rainy day. If you got 51 heads and 49 tails, you could be pretty certain it's due to chance. On the other hand, if you got 99 heads and 1 tails, you could be pretty certain that there's another factor at play. Say you're doing a mock experiment and you get 62 heads and 38 tails. Your observed for heads would be 62, while your expected would be 50, because there's a 50% chance of getting heads. For tails, your observed would be 38, and your expected would also be 50. Once you've identified your observed and expected values, just plug those values back into the equation. Once you plug in your observed and expected values, you'll solve your equation and get a chi-squared value. Do not forget the sigma, as you have to add together both values. In this experiment, you add together the heads value and the tails value. When you add the two, you get the final chi-squared value. In this experiment, the chi-squared value is 5.76. When you go to the critical value chart, you'll see that your value is greater than the 3.84 value. Since there are 2 possible outcomes, there is 1 degree of freedom. Because 5.76 is greater than 3.84, you reject your null hypothesis, saying there is another factor at play, such as a weighted coin.
Let me ask you a seemingly random question. When you think of the Olympics, do you look forward to an exciting round of curling, or maybe a riveting bout of equestrian jumping? Ponder that for a second. When scientists think of a chi-squared experiment, do they look forward to flipping more coins?
Nah, fam.
Thank you, Dylan. Let's get back to biology. A topic in biology that is related to chi-squared is the use of the Punnett square in genetics. According to the father of modern genetics, Gregor Mendel, a Punnett square allows a biologist to cross 2 organisms and predict the potential genotypes of the mating. Chi-squared testing allows scientists to determine if variances from the expected are due to chance or if there is something else at work. You'll know this if the chi-squared value of the results of the tested genotypes are greater than the critical value, meaning that the observed genotypes are not due to chance. One possible biological force at play is gene linkage, where 2 genes are almost always inherited together, even in the presence of crossing over, making it difficult to accurately predict genotypes with the Punnett square.
Alright, well, this has been chi-squared. We hope you guys enjoyed. This has been Dylan,
Mike.
Rohan?
And that's all we have for you today. Thank you.